So let's take a look at distribution of fractions, the idea of density of fractions. With whole numbers, we start at 0, and then there's this 1 unit jump to 1, and then there's another 1 unit jump to 2, and there's nothing in between there. With fractions, though, there's a lot going on. So, for example, between 0 and 1, right in the middle is a half. And then on each side of 1/2, we have some thirds. So like 1/3 is about over here, and 2/3 is about over there. And then maybe 3/4 is about over here. And then over here somewhere is 9/10, and here is like maybe 1/11. And there's a lot of different fractions in here. And so in between 0 and 1, but less than 1, so we don't count 1, these are the proper fractions, right? And the crazy thing about proper fractions is that there are infinitely many. Because we have halves and thirds and fourths and fifths and sixths and sevenths and eighths and ninths and tenths. We have 100ths and we have 1000ths, and all day long you can come up with new denominators. And as long as the numerator is smaller, they live somewhere in here. And if I zoomed in between, say, 1/3 and 1/2 here, which seem pretty close on that number line, but on a different scale, if I have 1/3 way over here and 1/2 way over here, there's a whole lot going on in between. And we could all day long find fractions. Now, it gets a little bit harder to find them between 1/2 and 1/3 than between 0 and 1, because between 0 and 1, as long as the numerator is smaller than the denominator and it's positive, they're in there. But like I could find the number in the middle, that would be the average of these two numbers, right? 1/3 plus 1/2 divide by 2. And we'd end up getting, let's do a little arithmetic here, 2 times 1, 3 times 1, and then common denominator is 6. So we get 5/6 for the top, divide that by 2. 5/6 times 1/2. So right in the middle here is the number 5/12. And that wasn't too hard of a bit of arithmetic. A calculator could help. So then you could repeat that same idea and find the fraction exactly in the middle there, and exactly in the middle there. And then do it again and find the fraction exactly there, in the middle, and there, in the middle, and there, in the middle. We can keep having every interval by just averaging two numbers. And so all day long we can find fractions, but there's a ton of other strategies you could try also. So for example, common denominator here, I just kind of discovered when I was playing around there. 1/3 would be 2/6, right? And 1/2 would be 3/6. Now there aren't any whole number of 6 between 2 and 3. But I could just kind of scale up a little bit, like what if these were 60ths? So this would be 20/60ths and 30/60ths. And there's a whole bunch like 21, 22, 23, 24, 25, 26, 27, 28, 29 60ths in between here. If you needed more, then maybe call them 600ths. So 1/3 would be 200 out of 600. And 1/2 would be 300 out of 600. And there's a heck of a lot of proper fractions living in between 200 out of 600 and 300 out of 600. Just kind of a modification of that strategy right there. I wanted to find some numbers in between. So let's see, we've got our 1/3 here and we've got our 1/2 over there. And someone says, hey, find 4 fractions in there. Okay, so the tricks I used earlier would work, but maybe I decide, 4 in here, I kind of want them equally spaced. So would this be about where they go? It's kind of equally spaced. So I want to know what this fraction and that fraction and that fraction and that fraction are, given that I'm trying to make all of these the same space in between. And so those 4 cuts give me 5 equal spaces. So there's space number 1, space number 2, 3, 4, and 5. So if I cut the space between 1/3 and 1/2 into 5 chunks, then I'll get 4 equally spaced numbers in between. So if I think about that in a common denominator, so 2 out of 6 here, 3 out of 6 there, and then we bring the 5 into it. So I multiply top and bottom by 5 here and here. So then this becomes 10 out of 30, and this is what, 15 out of 30. And so this right here should be 11 out of 30, and 12 out of 30, and 13 out of 30, and 14 out of 30. The next one would be 15 out of 30, which is 1/2. And so now, not only did I find 4 fractions in between, they happen to be equally spaced. And there's a ton of other strategies that one could come up with when they're playing around with this. So I'll leave it at that. This is the idea of density of fractions. Between any 2 fractions is another fraction, and it's actually more complicated than that. There's a ton in between any 2 fractions. Doesn't matter how close they are. So if somebody said, let's see, you can pick 2 numbers that are really close and then zoom in on them. So this could be 9,999 out of 10,000. And this is 1 over here, which is 10,000 out of 10,000. There are a ton of fractions living in there, and we can use the same strategies I've mentioned before and many others to find some of them. Crazy, crazy, crazy. All those fractions living together. Thanks for playing.